Well, last week we talked, so we've just been, you were here when we were doing the memory stuff. I
Hmm.
kind of started to mention data structures. Um, and I did a little bit, in that world, kind of like dipping our toes in. But I decided to step back and give everyone kind of a theory lesson last week. So it had no code, but it was just going over some theory. And I think I sent you guys a video. Um, Might be worth at least watching that video at some point because I think it's really interesting as to like why any of this matters in computer science. Um, Particularly this week, though, all I was going to do is I generated a couple different things to kind of close out the data structures and algorithm side of the
Hmm.
lessons before we move on to maybe stuff that's more interesting uh, to your careers. I would just copy and paste some of the C++ examples for various data structures and then various sorting algorithms into C++. Give it kind of the quick 101 of each of those, and then like kind of bounce and move on to other things that are maybe more interesting. So yeah. Um, so I have C++ up here. I just want to make sure that this will run. 'Cause it's been a while since I've done this. Uh, let's do G++ main.cpp. Okay. Slash hello.
I'm not seeing what you're
Boom.
typing.
I
Seeing
was, I was
ChatGPT.
sorry. I was just double checking it was going to work. Let me share
Okay.
my whole screen though. So it's uh, present something else. Let's do the entire screen. All right. Yeah. So it works. So copy this dynamic vector in here. So first data structure, vector. And vector is basically a dynamic array. So an array where arrays are fixed, vectors can grow. We talked about that before, right? So if I just G++ main and run the binary, boom, I get a list of the contents. You can loop through it with either a for loop or an iterator structure. Um, I think this is doing somehow it's doing both. Oh, it's like dumping out the entire array or looping through it. Um, and it's pushing an element onto it, showing that you can resize the array. So vectors are arrays that are resizable, straight lists. They're straight items in a sequence. Uh, Next, we have an array. Fancy enough. We're gonna show that again. An array is a fixed size, and you can change things, but you can't add to the size of it. So that's basically an array and a summary. A string. I'm just going to go through all these real quick. You have seen this before many times, but a string is actually a data structure in C++. So um, you can resize a string. So in this one, oh wait, I didn't click save on that. Not sure I clicked save on the last one too. But whoa, what's going on here? Save C++. G plus plus. I'm going to G plus plus dash out dash hello. I think I wasn't overwriting that. There, that worked. I might have to redo this. So that worked. And printed out hello. For sanity's sake, I need to do this to make sure.
He, he added
Oh,
hello or world to the hello. Yeah.
yeah.
String. Yeah.
Now I maybe I didn't click the save button. Why is that not shrinking? I'm gonna delete this random thing that's over here. Delete permanently.
I
Delete
think you're
permanently.
getting the output you want. You're getting
Yeah.
you're getting two on the far left, right? That's what you're trying to
Oh, I
pop off
am.
the right.
Okay,
Yeah,
good. It
it's
just
just
didn't
not
have an
indented.
indel. Thanks.
Yeah.
All right.
I
Maybe
was
it's
saying I said that like four times on mute, and
uh
I kept saying I think you're getting the output you want, and I realized I was on mute.
sure. That's funny. The next one is a map, which I mentioned but never showed you. A map is just a key value pair. Um, so, I mean, you can kind of think of an array as a key value pair, but it's based on a numerical index. Same with like a vector, but a map actually has like a different symbology, text, or object as the key that extracts the value from the array. So an example here of what this looks like, GCC hello, and then boom, it printed out 30 over here. But you'll see it's map, and then you put the type that you want into the map. So this is type string is the key. The value is a numerical number. The map is ages. And then I start to add things in. So I say, hey, I have a key for a key Alice. I want you to store the value 30. And a key Bob, I want you to store the value 25. And then, when I see out it, I just put in the key and it returns the value, and boom, we have 30. So it's pretty simple. A hash map is another type of map. And it's unordered. This map's technically ordered. And hash maps have certain qualities of retrieval data. To be honest, I don't remember all the details right now, but to give an example, showing you a hash map, boom, boom, we have sensor. And so numerical keys in this case, and again, certain utilities for retrieval of data, especially unordered data. Set. So here's an example of a set, unique ordered elements. And so we never talked about set theory. I have a good article on my website about that, but a set's kind of like a list. I don't know, right? But technically a set is usually a set's not ordered. In this case, it'll look like it's ordered in C++. I'll show you what it looks like. Not super common to use this, to be honest, from what I've seen in C++, but it put out 1 and 3. So here's the TLDR of a set. There's no duplicates in a set. That's like kind of even the mathematical theory of sets. There's no duplicates. So it's not like there's 2 3s in it. A set either has something or doesn't have something. So this right here, what we have created, would be considered the set of 1 and 3. No matter how many times I try to add 3 to it, it's just got 3. So you would check to see if the set has some object, and it either does or doesn't. There's no amount of copies. So that's set theory. And there's all kinds of things behind that in mathematics, like the set of all real numbers, or the set of all integers, or the set of all positive integers, or the set of all irrational numbers, or the set of all. And it's a way to define what is and isn't in something exclusionary. It's pretty fascinating. It's kind of one of the axioms of mathematics, set theory. Not used a whole lot from what I've seen, but there's definitely use cases if you just want to check if something is a part of a set. This is an unordered set. So this is more traditionally what you see is unordered set, where it's the same thing. It's just not in an order. Technically, in mathematics, in a ordered set is not actually set, because sets are not ordered. But it's all kind of semantics and how you're actually going to use it. You don't need to spend too much time on it. So basically, I found 2 because 2's in the set. A queue. I mentioned this a little bit to you. First in, first out. That's the most important thing in a queue. So it's just like basically a giant vector or list. But I'm going to put stuff into it. Either you can sometimes push to the back or the front, or pop to the back or pop to the front. There's different functions to do it, but you can think of it as a big queue, just like you're waiting in line for your piece of pizza or the cashier. And typically you're going to pop or push stuff onto the queue. So you might take the front of the line, and that is what this is showing. So I will give you a demonstration here. GCC, hello, hello. And it popped 1. So I built a queue of type integer. I pushed on 1 and 2. And then I said, hey, I want you to pop the front. So 2 was the first one pushed in, then 1 was pushed in, and then you pop the front, which is where things go in. And so you popped 1. Or you retrieved the front, but this pop action is kind of weird. It happens after the fact, so it's not actually printed, but you're actually removing it when you pop it. And the real way, by the way, you'll see this is you'll see like int a equals pop, because you'll pop it off, assign it to something, use it, and then you don't need it anymore in the queue. That's the real functional use that you'll see. Stack. Stack is like a queue. The only difference is instead of first in, first out, it's last in, first out. So just to define that terminology again, first in, first out is like with the traditional functions, when I push it in, if I pop it, the first one that goes in gets popped off first. So like it's kind of the first person who arrives at the bank in a line gets answered first. A stack is not that. It's the last in, first out. So it would be like if people came into the line of the bank, but instead of answering the first person, you decide you're going to talk to the last person who came in first. Really weird, but we use it sometimes. So that's really just the difference between a stack and a queue. QCC, hello, 20. 20 is the top of the queue because that was the last in, so it's first out.
So when you have those stacks and queues, is it when you're pushing it or when you're pushing it in, is it creating an array or a vector?
Under the hood, it's basically a vector.
So the difference,
it might be a linked list. Don't quote me, but it looks like a vector. Things are ordered, so it's in an ordered sequence.
So I guess the big difference between the stack and the queue then is like just the order of the vector. So
it's the pop function. It's all about the pop function.
But wouldn't the top vector be like 1, 2, and then the bottom vector be like 20, 10?
Last in, first out.
So like his pop is just taking the one off the top, I imagine. So like, is it how it orders the vector under the hood? So it'd be like the top one would be 1, 2, where the bottom would be 20, 10.
Here's the way to visualize a stack in a queue: horizontal and vertical. So I described it to you as a bank, but like a queue is horizontal. So when I push stuff in from left to right or on your screen, it would go this way. The first item that I push in, I'll just keep pushing and appending, and it slides like a train. And then when I use the pop function, it pulls off that first item out that went into the queue. A stack is like this big pancake, and so you can think of it as like a Connect 4 where you drop it down, right? So I drop something into the stack, and the last thing, which is on top of the stack, not buried at the bottom, I pull off.
Okay,
like a pancake.
That makes sense.
With the pop function. So the pop function behaves differently if it's a stack or a queue is the real.
So I guess the reason I asked like what the order of the vector looks like, would you ever want to iterate over a stack or iterate over
usually you are using a stack or a queue because you want the last in or the last in first out or first in first out methodology, meaning you're going to like, I have a bunch of data I'm trying to send somewhere, so I put it into a queue and I want the first piece that arrived because it's the most important information to go first, so I'm going to use a queue. When the other side of the queue is ready, it'll start popping stuff off it.
Got it.
Last in first out is the reverse. It's like maybe the old data doesn't really matter anymore, only the new data, so take the latest. That's really where it comes from. Double-ended queue, which is actually what we use in certain middlewares and stuff. You can talk to Chef about this. I think he loves double-ended queues, but the push front, push back, just taking our time here, is you can basically you can pop from the front or the back or push to the front or the back. It's like you can do both operations, I believe. That's the difference. And that semantically, you have to handle the memory linkage differently. Because I think these are all linked lists in memory, even though I told you they're a vector, because you can think of it that way. They're actually linked lists, so they're sporadic, if I'm remembering correctly. So double-ended queue has to have not just the pointer to the next piece of memory, but it has to have the pointer to the prior piece of memory. So you can go through the thing backwards. I hope that was right. That might not be totally right, but I think I explained that correctly. A pair is literally just a pair. It is a data structure that has a first and a second element, and you just assign the first and the second element. You could do, in this case, it's 1 and 3.14. And so depending on if you pull the first or second element, you get that data. Structure is a custom one. So you can build custom structures in C++. So this struct right here, I in this case, I build an aircraft, and the string comes. I build a string name. It's kind of like a class without methods. That's what you
Yeah.
can really think about. But like,
Okay.
and then a double of a weight, and I can use those. I can fill them. I can build new ones, kind of like class objects, except it's a data structure type.
So a data
Um,
structure aircraft has a name and a weight.
yep, and it really is so much like classes like, without methods. Is a really great way to think of it. There's not much else to it. That's pretty much it. Like for data structure that you're going to use commonly, there's really niche things, but that's most of it. The other thing I was going to talk about was sorting algorithms. So I'll just copy these in, but give you a quick thing. So what you missed last week was the big O notation, the theory behind
Mm.
these, but which you can kind of follow along in that video I sent you, and it's short. You'll come up to speed. But the idea here is swap. Bubble sort is you literally just swap components. And selection sort is select the minimum and place it at the front. So you'll notice like bubble sort, you start at the beginning and you go through and you check the two elements that are right next to each other, whichever one is bigger, for instance, or smaller, you make sure it's on the left side and you just keep swapping them. If you do that enough times, the list will end up in order. And so that's an algorithm called bubble sort, big O n of two, meaning it will, at a worst case scenario, it will take full uh, n squared sweep through the matrix of basically looping enough times to get it to work. Selection sort, it has the same n squared, I believe. But it's, this time you're going through the list and you're selecting, or you're going to move the element that you come across physically to the beginning so that it's always like the smallest ones are ending up there. I believe that's happening. And then you end up with a sorted list at the end. Insertion, insert each element into its proper place. I think this is more aggressive in terms of you have to kind of look at the list at the beginning and start to insert it into the ordering at the beginning each time, and you end up with an ordered list at the end. Computational based, big O of n log n is better than n squared. So merge sort is really popular, and you basically what you're doing is you're dividing. You start with an array, you divide it into halves. You sort each half, and then you merge them. And so what ends up happening is you end up dividing, sorting, and you kind of like come back up to the top with a fully ordered array. And the worst case scenario is n log n, which is better than n squared. Does that conceptually make sense? I can go through this algorithm. It would be pretty. I think it involves dynamic programming, looking at it, which is a little bit complicated for your background. But visually, if I take a list of unordered elements, they're not ordered initially, and from the highest to lowest or lowest to highest, and I cut it in half, and then I decide I'm going to cut those two in half, and then I'm going to cut those two in half, like a span tree, right? Eventually, I will come down to where I have two elements, and I look at those two elements and I get them in order. And then those are in order, and I get the next ones in order, and I get the next ones in order. Maybe that doesn't work.
So I guess I understand it conceptually, like how it works. What I always struggle with for this is like when to use these. Like, is this to be used? Like, when do you need to order a list? Like, what's a use case of that?
Grades. I'm like, I'm a teacher, and I want to find out who got the highest score and kind of what the distribution is of the score. So I have a bunch of scores in my list, and I click the Excel button that says order these top to bottom. Excel's actually using probably merge sort under the hood to sort them top to bottom and then order the rows.
Got it. So it's almost like instead of, because like my background is like a for loop, right? So like one way that you could do that as a teacher is create a for loop and say like if this one's higher and go through each one, but that's going to be short. That's going to be a worse O than the merge list is what you're saying.
Correct.
Yeah.
I want to describe merge.
It's a way to. It's a way. It's all of these are like a way to iterate over data.
Yeah.
To get something. Okay.
It is recursive. I was right. It is recursive. we haven't talked in depth about recursion. I might tell you about it at some point, but a for loop is recursive. A while loop is recursive. That
I'm
just means
aware.
run the same function over and over again.
Yeah, function
Right.
that calls a function. Yeah.
Yep. And so merge sort is that type of function, which is why if you look at the code, it's going to call itself. Merge is going to call something. Yeah. So merge short calls merge short, calls merge short, and then eventually calls merge at the base layer, and just keeps like recursively coming out and then coming back. Quick sort, I'm not 100% sure. I think this might be big O login as well. Partial pivot. It's just adding a little bit more logic to like a swap function, I think. Heap sort's a little different. I'm not 100% familiar with it. You can study some of these on your own too. Counting sort, like they get more niche. You're not going to use a lot of these. Bucket sort, like hybrid reward sorts. But big O of log in is about the best you can do. And my point in showing you some of these was just to give you a feel for like why you would use them. And if you ever need to use those, you now have a method, by which you can be like, hey, what's my big O of this sorting algorithm? I should probably use one of the best sorting algorithms. Let's try to formulate it to use one of the best sorting algorithms. Yeah. So that hopefully that gives you a little bit of insight.